Welcome to Cybersecurity Workshops, and in this session we're going to talk about file directories and permissions. So this is going to be, so we've had a couple of relatively short sessions, 10 to 15 minutes. This one's going to be a little bit longer, and it's going to be a little bit more complicated than the other discussions. Complicated in that it's a little bit more advanced features of files and directories. And so what I would suggest is that people go ahead and pause this video, grab a piece of paper and a pencil and write some of this down, because there's some things, and I'll mention some things that you might write down along the way, because again, some of these topics are a little bit more advanced, but as you advance in your usage of the Linux file system, you're going to want to be able to manipulate some of these various functions. Okay, so we're continuing on with our Introduction to Command Line Interface. This is a course in the Virginia Cyber Range courseware repository by Matthew Vogel. And teachers, if you want to find the other resources associated with this course, then you should go to the Virginia Cyber Range courseware repository, log in as an instructor, and search for command space line. You'll find a course called Introduction to Command Line Interface. And right now we're in the middle of module 2 from that course. Okay, so we'll dive right in here. File and directory permissions. I've thrown out this word permissions a couple of times as we've looked at the long directory listing, and I've said, don't worry about it right now, we're going to come back and talk about it. Well, now we're coming back to talk about it. So here's some objectives. We want to understand file and directory permissions and what that means. We want to understand the sticky bit, understand how to change file and directory permissions, and then we'll look at the sudo command. Sudo. It's like some foreign language. So file and directory permissions. Each file and directory in the Linux file system has 3 sets of permissions: owner, group, and others. Okay, so the owner of the file has some permissions. RWX, read, write, execute. The group has some permissions, read, write, execute, and then others have some permissions, read, write, execute. Okay, so what that means is that when you create a file, there's going to be some default set of permissions, and the default permissions are generally pretty permissive in that if I'm a standard user, I'm going to get the permissions that are appropriate for that file. So if it's a text file, for example, as the owner, I'll get read permission and write permission. I won't get execute permission. And why won't I get execute permission? Well, if it's not an executable file, then the default permission shouldn't be that I can execute it, right? I can add the execute permission, and that won't do anything for me, because if it's not a program that the system recognizes as an executable program, then I won't get that permission. So I mean that explains why, when I create a file, why don't I just get R, W, and X permissions for any file that I create as a user? And the reason why you're often not going to get an execute permission is because the file cannot be executed. Okay, so there's RWX permissions, and again, these are going to be pretty permissive if I'm just sort of out there creating files in a default way. And then the group that I'm in are usually going to get the same permissions that I get as the owner, and the default behavior is generally that others are going to get those same permissions. When I say others, that means everybody else who has access to that system. And so this is why we care about file permissions. I may want to set file permissions on a system, particularly on a shared system, that disallow other people access to the files and directories under my control, right? If I'm using a shared system, like in a lab environment, so maybe I have maybe there's a Linux system in a lab environment, multiple students are able to log into that Linux system. If you don't do something to manipulate the file permissions, then anybody can get into your stuff and see your documents and your data, and that's not always an ideal situation. And then on the other hand, there may be times when you're the root user of a system, and when you create stuff as the root user, then the root users, administrative users are going to have certain permissions to be able to manipulate those objects. But the default behavior is that others will not have those permissions. Others meaning people who are not root users. And sometimes you want to give non-root users access to stuff. And so you'd have to do some file permission manipulation in order to do that. So the three possible permissions are R, W, and X, and again, owner, group, and others. And let me just show you where you see that. So here I am in my home directory. And remember, we do this ls-l to get a long directory listing. And here's where you see at the very beginning of each file, the listing for each file, you see the list of permissions for the owner, RWX for the owner, RWX for the group, RWX for everybody else. And so here we see that in these directories that have been created in my subdirectory, I have read, write, and execute permission for the directories, so I can change into those directories. Read, write, and execute. I can change into the directory. I can see it, and I can change into it. And the write permission gives me the permission to delete it. My group, people in my group have read permission, they have execute permission, so they can see the directory, they can change into the directory. If they're in my group, they don't have write permission, so they can't delete the directory. So I could give the group write permission, and I'll do that in a few minutes as we look at some of this. And then with everybody else, again, everybody else has read permission, they have execute permission, so they can see that directory, they can change into it. What they can't do is they can't delete it because they don't have write permission. But this is where I see these permissions. It's right after the indicator, the file type indicator, if you recall from an earlier discussion. At the very first character in the directory listing is the file type. It could be a dash, which means a regular file, could be an L, which means the link, could be a D, which means the directory. And then right after that are 9 characters with the file permission information. Okay, so read permission. Read permission on a file allows you to open and look at the contents of the file. Read permission on a directory allows you to list ls the contents of the directory. The read permission on a file also allows you to copy and move a file provided you have proper permission on the directory. So you have to have write and execute permission. So you can copy a file in the directory if you have write permission in that directory. If you don't have write permission in the directory, then you can't create any new files in it, so you can't copy a file to another file. And we haven't talked about copying and moving files yet, but we're going to do that very soon. So that's what read permission does. Should be fairly straightforward. Write permission allows you to edit the contents of a file. So if I have write permission on a file, I can modify the contents. Write permission on a directory allows you to copy files in the directory and move files into the directory. However, the write permission on a directory must be paired with the execute permission to enable CP and move commands to work. So you gotta write and execute in a directory in order to move files and copy files. And again, we're going to talk about copying and moving files soon. Execute permission lets you execute. The execute permission is only meaningful on a file that is executable. So it's got to be a script or a program. That allows you to execute the program. So you can't have it is possible to have an executable program in your file system that for which you give others read access, but you don't give them execute access. So they can get in there, they can see the file, but they can't execute it. And then execute permission on a directory allows you to run programs located in the directory. And then again, the execute permission paired with the write permission allows you to change into the directory and then copy and move files in the directory. And this is what we just saw, right? When you do an ls-l, you see the permission data right here. Okay, the sticky bit, this is a little bit of an advanced concept, so I'm going to talk about it. And you may see this sometime soon, you may not, but I'll just talk about it. So if you hear this term sticky bit, you'll have a sense of what it means. The sticky bit is a special permission that can be assigned to a file or a directory, and it basically is locking things down so that the file or directory can only be deleted by the owner or by root. And so there are times when you're going to want to give people read and write permissions, right? So you might have a group thing, a group project where, you know, I'm going to change the permission of a file that is observable by my group, but I'm going to give my group both read and write permissions so that they can not only read the file, but they can edit the file. But I don't want anybody to delete that file, because I know that maybe my partners are not super adept at the command line, and I know that they might accidentally do RM and then some wild card and accidentally delete the file, and I want to prevent that from happening. How do I prevent it? Well, I use this thing called the sticky bit. And the sticky bit shows up on the file permission as a T on the right-hand side. So this is what it's talking about right there. On the far right side of the permissions, there's this capital T, and that indicates that the file can only be deleted by the owner of the file or by a root user. Okay, and the chmod command is what we're going to use to change permissions on files or directories. Chmod, change mode. It's used to change the file permissions. So the name of it maybe doesn't make a whole lot of sense. Maybe it should be change chperm or something, but whatever. Change mode, chmod is what you'll hear it referred to as, and that's what we're going to use to change permissions on a file. So there's a couple ways that you can use the chmod command. You can use it with letters, and so when you use it with letters, you're going to have three parts. You're going to have the target. The target's going to be user, group, or other. The operation, that's either to set the permission or to remove the permission, and then the permission itself, and that's going to be read, write, or execute. So again, chmod targets are whom the command applies to. So it could apply to owner, group, other, or all. So UGO or A. And you should write this down. So pause and write this down. The target are UGO or A, other group, owner, group, other, or all. The operator, this is simple, right? You're either going to add a permission or you're going to delete a permission. So plus means add the permission, minus means take away the permission. And then you specify the permission, read, write, or execute. So R, W, or X. So you should write that down. Pause, write that down. Okay, so we're going to put all this together, right? We're going to use the chmod command with letters using the following format. We're going to say chmod, and then we're going to give the target, the operator, the permissions, and then the file name. And here's an example. We're going to chmod u. Who's that? That's the user, right? We're going to do a plus. It's going to give that permission where the user didn't have it before. And then we're going to use the X. Then what permission is that? It's the execute permission. Okay, so let's see this in real life. So I have this thing called output file. It's right here. Output file. And if we look at the permissions, I'm the user, right? Remember, the user's permissions are shown first. So I'm the owner of the file. R, I have read permission, I have write permission. I don't have execute permission. And then my group has read permission and others have read permission. Okay, so I'm going to change the permission of that file. I'm going to say chmod u. So that's the user, the owner of the file, plus, so I'm giving a specific permission, and I'm going to give the execute permission, and then I specify the file name. Okay, so I just did that thing. Now let's look at this file listing again. So now look at this, my output file. So it was white here, listing was white here, now it's green. Why is it green? Well, because now by changing the file permission, I'm making the system think that output file is an executable. It's not, but I just made the system think that it is. And now you'll see that where I had a dash here, I now have an X. So I could do the same thing to the group, right? I could say chmod G plus X. So that's going to give the group the execute permission. Then I put the name of the file. Now I do it ls-l. Okay, and now it changed again, right? Read, write, execute, read, blank, execute. I can also remove permissions using the minus, right? So here I say chmod G and O, so I can group these together. So I was doing a single target and a single permission at a time. I can do multiple permissions. So here, this is going to apply to the group and to others, and I'm changing the write and the execute permission. Okay, so let's try that. Whoops, let's try that. I'm going to say chmod minus X. Whoops, chmod user and group minus X output file. When I do that, what happened? Look at the output file here. I took away the execute permission from the owner of the file and from the group. So up here, output file, the group and the owner had execute permission. Now I've taken that away using this command. Chmod user and group, I'm taking away a permission. The permission I'm taking away is execute. And the name of the file is output file. Simple, right? And I can group these together, right? So I can put multiple on a line. I can say add the execute permission to the user and remove write and execute permission from the group and from others, and then the file name. So I can make these arbitrarily complicated by using commas along the way. And I can use the A target to do this for everybody, right? So if I go back here, and again, output file, nobody has execute permission right now, so here's output file right here. And if I look at the permissions, read, write, blank, read, blank, blank, read, blank, blank. If I want to give execute permission to everybody, I can say chmod A plus X, output file, boom. Now everybody has execute permission. Here's output file. And everybody is able to execute. Of course, they can't execute the program because it's a text file, but that file permission makes the system think that it's an executable file. So now I can say chmod A minus X output file. Now I've changed it back, I've taken away that spurious execute permission that shouldn't be there. Okay, so that is using characters to specify permissions. You can also do this using numbers. This is what old school people do. They use numbers all the time. Each permission is assigned a number. So read is 4, write is 2, execute is 1. Simple so far. I can add these together. So if I want to just specify a read permission, I can say 4. If I want to have read, and if I want to have just, if I want to just change permission, the read permission, I specify 4. If I just want to give write, then I specify 2. If I just want to give execute, I specify 1. If I want to do read and write, then I could do a 6, because that's 4 plus 2. If I want to do read, write, and execute, I could do 7. That's 4 plus 2 plus 1. If I want to do read and execute, what would I use? I use 5, because that's 4 plus 1. If I just wanted to do write and execute, what would I do? It would be a 3, right? So 5 is read plus execute, and 3 is write plus execute. It's because it's this binary numbering system, and it's the reason that it's 4, 2, and 1 is that I can uniquely identify each of the different permutations by using a single number. Okay, and why would I want to do that? Well, I'm gonna assign all of them at the same time. So each file or directory has 3 sets of permissions: owner, group, and others. When using the numerical method, all 3 sets must be accounted for, and you can't add or remove single permission. Add or remove single permissions to letters, but you can do so using numbers. So here I do chmod owner, group, others, and then the file name, and here I'm using numbers. So here, for example, and I got to include all 3, so there's going to be 3 numbers every time, and I'm setting this. These are always setting the permissions. So I may be taking away a permission when I set the permission, but here I'm setting the permissions. So if I say 0 on any of these, then all permissions are going to be taken away from that column. And again, that's user, group, and others. So here, for example, I'm going to give read, write, and execute for the owner. So 7, read, write, and execute. Remember, read, execute, and write. I'm gonna give read for the group and others, right? So read, write, and execute for the owner, read for the group and others, and that's the 4. Remember, 4 is read all by itself. The following example will set read and execute for the owner and the group and no permissions for others. Okay, so let's do that. So we'll look at output file. So I'm going to say chmod 744 output file. 744, remember that is read, write, execute for the user or for the owner, read and read for group and others. So again, I gave this execute thing. So let's do a thing where we set the permissions back to let's do this. Let's set permissions to read and write for the owner. So here's a test for you. We want to set read and write for the owner. We want to give no permissions to the group. We want to give no permissions to others. What would that look like? Chmod. If I want to give read and write, that's going to be 4 plus 2, which is 6, right? I want to give read and write to the owner. I want to give 0 to the group, because I want to take away all permissions from the group, take away all permissions from others. Output file. And so here I have just what I wanted. Read, write, nothing else. Now let's say I want to give that read permission back to the group, but I don't want others to be able to read the file. If I wanted to do that, I would say 640. Remember, the read permission is 4, 640. And there we go. Got what I wanted. There's my output file. Read, write, that's the 6. Read for the group, that's 4. 0 for others. No permissions for others. Okay, and the final thing we're going to do is we're going to set the sticky bit on that file. So I can say chmod plus T and then the file name to set the sticky bit, or I can use a 1 at the very beginning of my numerical file permissions. And the easiest way to do this is just to use the plus T. So now if I say chmod plus T output file, now I get that sticky bit set, right? There's that T at the end that says you cannot delete this file unless you are the root user or the owner of the file. Unsetting the sticky bit, you do the minus T, right? So chmod minus T output file. And now it's not sticky anymore. Changing the owner, you can change the owner of a file. And for chown, you got to be root, right? So if I want to change the owner of a file, I use the chown change owner chown command. So with chown, I say new owner, and then the name of the file. And I'm using sudo to do that. So sudo we haven't talked about. Sudo is short for super user do this thing. Super user do, yeah, sudo. And sudo lets you, if you have the right permissions, sudo lets a user take action as the root user. And here we have an example. Okay, so here's more about sudo. When using a Linux system, currently best practice is to use a normal user account instead of the root account, right? So we don't, lots of times, lots of system administrators won't even allow anybody to log into a system as root, because if you're the root user, username root, you have permission to basically do anything on the system, and that can be very dangerous if you are doing things as the root user. It's you know, you can if you type the wrong thing, you could delete, as we mentioned previously, you could delete whole branches of the file system and cause the system to be unusable. So normally you never log in as root. You use sudo if you need to do a thing that root needs to be able to do. As a normal user, however, you need to have ability to elevate your privileges to do certain things, right? So the sudo command, super user do, will give you the root level permissions you need. Not every user can use sudo, and there's a specific way to give that ability to people, and we're not going to talk about how to do that right now, but we'll talk about it later on. In the side range, a student account has permissions to use the sudo command. So the student account can do things that normally only root can do. When you use the sudo command, it's going to ask you to provide your password. So you don't have to know the root password in order to use the sudo command. If you have permissions to use sudo, it's going to ask for your password when you try to use sudo. So let's do this chown thing real quick. The output file, I'm going to change the owner. I'm going to say sudo chown root output file. That's interesting, huh? So here, I just changed the owner to root. So root owns output file. Okay, and then I can also change the group. So if I have a file that I create and I want to make only certain members of a certain group have access to the file, then I can change I can change the group ownership of the file as well with change group. So you got to do sudo again, sudo change group root output file. So this is interesting. Now, the output file, remember I created it, I'm student, I created it. Root's now the owner, and root is the group. Okay, so now can I see what's in there? Cat output file. Ah, look at that. Look at the permissions on output file. The owner of the file can read and write it. The owner of the file is root. The group that the file belongs to can read and write it, so root can do that. And then others can do nothing. And right now I'm an other, right? Even though I created that file, I used the sudo command to give ownership to root and to change the group to root. I'm not in the root group, and I'm not root. I'm student, so I can't do anything with that file. So how do I make it so I can get to it again? Well, what I could do is I could say change group. Whoops, I got to do sudo, right? Sudo change group. I want to change the group back to student. And there's the name of the file. Okay, now can I do that? Yes. Now let's look here. Am I the owner of the file? Not the owner of the file. Root still owns it these days. Student, it's in the student group though, and I'm in the student group because student is my group. And so that's why I can read this file, because the group has the read permission. If I was to change that R, if I was to get rid of that read permission for the group, then I would not be able to see it, because again, root is the owner. Okay, so that's files and permissions, and you should now dive into the file and directory permissions lab exercise. And thanks for joining. We'll see you next time.